It takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old.
Another cosmic puzzle needs to be solved. The JWST has received up signals from our neighboring galaxy.
Just 2 minutes ago, the James Webb Telescope received a troubling alert from the Andromeda Galaxy. Astronomers have long studied our galaxy, the Milky Way, and others, keeping an eye on cosmic evolution. During a recent study, they detected a worrying signal from Andromeda, indicating an upcoming catastrophic event. While this event may unfold over millions of years, the telescope's alert has raised concerns about our planet's fate. Can we do anything to avoid the disaster? Join us as we explore the unsettling message from Andromeda that has devastated the scientific community. James Webb Telescope receives shocking signal from the Andromeda Galaxy. The Andromeda Galaxy ring-like transition may seem like a beautiful thing because it is a rare phenomenon, but it is far from it. When a spiral galaxy transitions into a ring-like galaxy, it means interaction with other galaxies, and the most common interaction we know is collision. Although it may not seem like anything, Andromeda's future is directly tied to the Milky Way. This means that it must interact with the Milky Way in one way or the other during its transition. The transitioning signal from the James Webb Telescope suggests that the Andromeda Galaxy would collide with the Milky Way in about 4 billion years, but it would not be a direct collision because of the distance between both galaxies. According to scientists, the event would be so catastrophic that it would reshape both galaxies entirely. The interaction between both galaxies would eject gas and dust, leading to new clusters and star formation. The interaction between both galaxies would eventually result in a cosmic event known as the single elliptical galaxy, and it's going to change the course of the universe with humans. During the collision between the Andromeda Galaxy and the Milky Way, the black holes in both galaxies would also merge. The coming together of these massive black holes would result in a severe radiation emission. So if these black holes are multi-million times larger and heavier than the Sun, would the merger affect our solar system? What would it mean for humans? It is a huge possibility that the collision may not affect our solar system. It's going to cause a shift in the regular system of the Milky Way. A massive shift. The aftermath of the Andromeda Milky Way collision. Since the signal suggesting an intergalactic collision between the Milky Way and the Andromeda Galaxy was discovered, scientists have been conducting cosmic research to accurately predict the aftermath of the collision and its impact on humans. The Andromeda Galaxy contains about 1 trillion stars, and the Milky Way contains about 300 billion. Although star-on-star collisions are likely unlikely during the merger of the Andromeda Galaxy and the Milky Way, the gravitational field formed by the collision can send the stars in these galaxies into new trajectories. But what could it mean for our solar system? What happens if the Sun enters a new orbit rather than ours? The collision could have serious repercussions for Earth's climate. Humans need the impact of the Sun on the Earth from a particular distance. If the distance from the Sun to our galaxy is changed, our climate could get hotter or cool down. Either way, it is going to have a catastrophic effect on the residents of the Earth. Scientists predict sometime during the collision, there is a 12% chance that the solar system could be entirely ejected from the newly formed galaxy. If the climate gets warmer and the new distance from the Sun to the Earth is closer, the Sun can melt water bodies and cause the sea level to rise, which means extreme flooding, since about 70% of the Earth is covered in water. It can also directly affect humans, as there would be extreme heat and high levels of dehydration which can lead to death. However, if the Sun is further away from the Earth and the climate is cooler, it can trigger another ice age, and plants and animals would suffer. Aside from the direct impact on the climate, the collision of the Andromeda Galaxy and the Milky Way would cause extreme radiation when the black holes come together. This radiation would release high-energy particles into the atmosphere and the surface of the Earth, causing every living organism to undergo irregular mutation. It would also impact the biodiversity that we have enjoyed as a race. The collision would be gradual, and both galaxies would work their way towards each other over millions of years. Imagine a clear sky, and then some decades later, it looks like something is creeping into the atmosphere. something mysterious. Before 2012, all the scientists had were speculations. They could not say for sure if the collision was going to happen or not. In the early 1900s, when the road to the discovery started, astronomer Vesto Slipher measured the radial velocity of Andromeda. In other words, he calculated the speed at which the galaxy was moving toward or away from Earth. Slipher did this by looking for a telltale stretching or compression in the light from Andromeda arriving at Earth. According to his experiment, light from objects that are moving away from us is slightly stretched or red-shifted. Light from objects moving toward us is blue-shifted or compressed. Realizing what he found, Slipher wrote in the Lowell Observatory Bulletin in 1913, "We may conclude that the Andromeda Nebula is approaching the solar system with a velocity of about 300 kilometers per second. However, after using Hubble to track the motions of stars in Andromeda with unprecedented accuracy, they came to an undeniable collision that the two galaxies would surely collide. We compared images taken at different times with the Hubble Space Telescope and measured how much the Andromeda stars have moved relative to the fuzzy galaxies in the distant background," says astronomer Sang-Mo Tony Sohn. "This gives us a sense of how fast the Andromeda stars moved across the sky." Two scientists with the Harvard-Smithsonian Center for Astrophysics suggested that all the activities involved in the collision would be determined by Andromeda's transverse velocity. According to their calculations, there is a 50% chance that in a merged galaxy, the solar system will be swept out 3 times farther from the galactic core than its current distance. When two spiral galaxies collide, the hydrogen present on their disks is compressed, producing strong star formation, which is not an unusual phenomenon in the universe. In the case of the Andromeda Milky Way collision, it is believed that there will be little gas remaining in the disks of both galaxies, so the mentioned starburst will be relatively weak. The truth is, by the time the two galaxies collide, the surface of the Earth will have already become far too hot for liquid water to exist due to the gradually increasing luminosity of the Sun, ending all terrestrial life. But let's start at the beginning. Technological advancement has contributed to our advanced knowledge of the cosmos, but before then, how did the world know about the Andromeda Galaxy? The first galaxy discovered by Galilei. Over the centuries, from generation to generation, people have coined and believed different perceptions about the sky and the galaxy we now know as the Milky Way. Some people believed that the whitish, cotton-like blanket in the sky was a place where the terrestrial and the spiritual forces met. Others just believed that it was the end of the world. And before you claim that these people were close-minded, remember that limited technology contributed a lot to how far they could think, till about a century ago. But before then, Galileo Galilei, an Italian astronomer, already painted something about the real picture behind the skies. He was already telling the people that the world did not end with a woolly blanket. In the 17th century, Galilei broke ground in astronomy when he made mind-blowing observations of the Milky Way using his newly developed telescope. While Galilei was carrying out one of his experiments, he noticed something extraordinary. He experienced something that was beyond the mental capacity of any human at that time. He saw that behind the whitish light was a vast world of individual stars, planets, and other extraterrestrial objects. When Galileo identified the visible Milky Way as a thick band of stars that wrapped around the Earth, it was hard for anyone around him to understand, because to them, the Earth was the only thing they knew. Galilei also punctured the theological belief that the Milky Way housing the Earth was at the center of the universe. Instead, it was a tiny galaxy in a vast collection of stars throughout space. In 1750, English astronomer Thomas Wright published his book, An Original Theory or New Hypothesis of the Universe. In his book, Wright said that the Milky Way was a flat layer of stars, a part of which was our solar system. It was not a random distribution. While Wright took detailing the Milky Way a little further than Galilei, he still had little to go on with. He was also limited by the observatory's technological equipment they had at that time. If he wanted the science world to hear what he had to say, he needed more. While he could not evolve his theory further, the world believed what they wanted to believe about the Milky Way. In the 1780s, William Herschel surveyed the stars in a range of different directions. He found that the stars were much denser on one side of the sky than those on the other side. He could not understand why. It seemed like the world was quiet, and the evolution of astronomy had died till the 1900s. In 1920, American astronomer Edwin Hubble conducted an incredible observatory experiment with a 100-inch Hooker telescope from Mount Wilson Observatory. With the telescope, Hubble observed distant nebula beyond the Milky Way. He noticed that many objects previously thought to be clouds of dust and gas and parts of the Milky Way were entirely different galaxies. According to Hubble, these clouds of dust and gas were too distant to be part of the Milky Way. Each of these galaxies contains billions of stars. One of the galaxies Hubble observed was the Andromeda Galaxy, which is the closest galaxy to the Milky Way. But shockingly, he was not the first. Andromeda Galaxy was first mistaken for just a small cloud. The Andromeda Galaxy was first discovered in the 10th century. Around the year 964, Persian astronomer Abd al-Rahman al-Sufi was the first to describe the Andromeda Galaxy. Digressing a little, can you imagine what al-Sufi would have been thinking to even decide to research space? What was the world like at that time? You would imagine that the last thing anyone would think about would be that anything was behind the skies, but al-Sufi thought differently. His discovery could be credited to his consistency because there was no way he saw the Andromeda Galaxy at first glance. He probably looked hard and then came back the next day and the next just to deduce that there was something different in the sky. He would have spent hours just studying one spot before telling the difference. Al-Sufi wrote a book about his thoughts on the Andromeda Galaxy. He called it the Book of Fixed Stars. In his book, Al-Sufi referred to the galaxy as a small cloud because it can only be visible to the physical eyes in the night skies. However, one thing that hit the scientific world as a mystery was how Al-Sufi observed the galaxy. He knew significant information, but he never had access to a telescope or any sophistication that the later world had. Yet about the presence of this galaxy. We can only deduce that Al-Sufi told an observatory story of his night watch, relying solely on his eyesight. He knew a little about it without the application of any equipment, because the Andromeda Galaxy is the only other galaxy that you could see from the surface of the Earth. After Al-Sufi, nobody talked about the Andromeda Galaxy till about half a millennium. He was like a rare genius who saw what others could not see. In 1612, the German astronomer Simon Marius gave a more advanced definition of the Andromeda Galaxy, but this time with the use of telescopes. Marius's work laid the foundation for future astronomers to study several mysterious cosmic structures. Then, in 1764, French astronomer Charles Messier catalogued Andromeda as Object M31 and incorrectly credited Marius as the discoverer despite its being visible to the naked eye. He forgot that Al-Sufi had talked about this structure. For the next century and beyond, astronomers across the world started carrying out observatory experiments on the Andromeda Galaxy from generation to generation. And through the years, these astronomers added knowledge gaps to previous findings, till the world was able to get a clearer picture of what the Andromeda Galaxy looked like. In 1864, about 100 years after Charles Messier discovered it, English astronomer William Huggins made a groundbreaking discovery about the structure of the Andromeda Galaxy. His discovery was so profound that it was nothing like anyone had ever seen. He observed the spectrum of Andromeda and noticed that it was different from that of a gaseous nebula. The spectrum of Andromeda displays a continuum of frequencies, superimposed with dark absorption lines that help identify the chemical composition of an object. The viral mass of the Andromeda Galaxy is of the same order of magnitude as that of the Milky Way, at 1 trillion solar masses. Huggins was blown away. He imagined a colossal galaxy, probably a significant percentage bigger than the Milky Way close to Earth, and we could only see it as a small cloud with our naked eyes. According to centuries of cosmic research, the Andromeda Galaxy is said to be about 10 billion years old. This estimation makes it one of the oldest galaxies still traveling the cosmos, with a long history of formation and evolution. According to a scientific theory, the Andromeda Galaxy was formed from the collision of several smaller photogalaxies. This means that about 10 or 9 billion years ago, smaller galaxies came together and merged to form the big Andromeda Galaxy. But as unrealistic and vague as the collision of galaxies might sound, it is not uncommon in the cosmos. Several galaxies have collided and will collide over the next billion years. It would be such a gradual process that you would not notice till you leave the surface of the Earth. For centuries, astronomers assumed that since the Milky Way galaxy was all they knew, it was the biggest. This was because it housed billions of humans, animals, natural bodies, and activities, since it includes the solar system and the Earth. There was also no record of any life in any other galaxy, so scientists assumed the Milky Way was bigger than the Andromeda Galaxy. However, they were in for an exciting surprise, one that would change the course of objective astronomy forever. The Milky Way is not so big anymore. When you look at the Andromeda Galaxy from Earth, you would think it's just a small patch in the sky. And if the Earth is bigger than what you can see around the environment, then the Milky Way should be magnificent. Nonetheless, a little cosmic research about the Andromeda Galaxy suggested that the Milky Way was not so big anymore. Excluding the large and small Magellanic Clouds visible from Earth's southern hemisphere, the Andromeda Galaxy is the brightest external galaxy visible in our night sky. At 2.5 million light-years, it's the most distant thing we humans can see with the unaided eye. This means that the Milky Way is closer, which is our world. So it is logical to assume that the things we see at a shorter distance are bigger than the things that are farther. With the unaided eye, most people see the galaxy first around August or September, when it's high enough in the sky to be seen from evening until daybreak. As big as the Andromeda Galaxy is, it is a lot similar to the Milky Way. The Andromeda and Milky Way galaxies reign as the two most massive and dominant galaxies within the local group of galaxies. The Andromeda Galaxy is the largest galaxy of the local group, which, in addition to the Milky Way, also contains the Triangulum Galaxy and about 30 other smaller galaxies. With continuous research, scientists have been forced to reduce the mass of the Andromeda Galaxy, if not lower than the Milky Way. However, something about the M31 galaxy remains undeniable. The unreal structure of the Andromeda Galaxy. The appearance of the Andromeda Galaxy in visible light seems like a small spiral cloud, but it gets better. Infrared data from the Spitzer Space Telescope showed that Andromeda is a barred spiral galaxy, like the Milky Way, and is inclined an estimated 77 degrees relative to Earth. The diameter of the Andromeda Galaxy is said to be between 100,000 and 175,000 light-years. The estimated distance from our world was doubled in 1953 when it was discovered that there is another, dimmer type of Cepheid variable star. This estimated diameter makes the Andromeda Galaxy a massive one that is hard to overlook. According to recent studies, the Andromeda Galaxy lies in what is known as the Green Valley, a region populated by galaxies like the Milky Way. The Andromeda Galaxy is surrounded by a huge halo of hot gas that roughly contains half the mass of the stars in the galaxy. The halo is enriched in elements heavier than hydrogen and helium, formed from supernovae. These elements are ejected from star activities, and the halos are almost invisible. They stretch about 1 million light-years away from the Andromeda Galaxy. The Andromeda Galaxy harbors a dense and compact star cluster at its very center, similar to our galaxy. With all of these discoveries, it was hard. Finding little details about the Andromeda Galaxy is a hard job. If astronomers were to consistently give an estimation of certain details like the diameter, distance, mass, and luminous intensity of the Andromeda Galaxy, they would need sophisticated equipment. This need presented a glowing lack of technological advancement over the last few centuries. But here we are. The world is at the heart of technological advancement. Every day, scientists, physicists, astronomers, and cosmologists find ways to make their equipment more sophisticated so that they can introduce more details into cosmic discoveries. In 1991, the Hubble Space Telescope was used to image the Andromeda Galaxy's inner nucleus, and scientists found a very interesting phenomenon. The nucleus consists of two concentrations separated by 4.9 light-years. The brighter concentration is offset from the center of the galaxy. The dimmer concentration falls at the true center of the galaxy and contains a black hole. The mass of this black hole was estimated to be 1.1 to 2.3 multiplied by 10 to the power of 8 solar masses. When the scientists converted their calculations to a layman's understanding, they gasped. The mass of the black hole weighed approximately 110 to 230 million times the size of the Sun. Before the use of an advanced telescope, scientists gave a hypothesis that the brighter portion of the double nucleus was the remnant of a smaller galaxy which the Andromeda Galaxy fed on. However, further research put a dent in the hypothesis, as the remnant galaxy would have had a shorter lifespan. The Andromeda Galaxy also has another fascinating feature. It has a massive collection of globular clusters, which are a close group of stars that orbit around the center of the galaxy, all in unison. The Andromeda Galaxy houses about 460 globular clusters, each of them containing millions of ancient stars that formed around the same time. The biggest of these clusters, identified as Mile 2, nicknamed Globular 1, has a greater luminosity than any other known globular cluster in the local group of galaxies. It contains several million stars and is about twice as luminous as Omega Centauri, the brightest known globular cluster in the Milky Way. The beautiful thing about these clusters in the Andromeda Galaxy is that they have a vast age range, wider than that of the Milky Way. Since the Andromeda Galaxy is spiral-shaped, it is an ideal place for smaller galaxies to merge. What happens to smaller galaxies if one of the biggest local spiral galaxies is about to change to something else? A developing ring-like transformation. Recent scientific observations of the Andromeda Galaxy have suggested that the galaxy could lose its original spiral shape as it appears to be transitioning to a ring galaxy. The ring galaxies are relatively rare in the cosmos, and they have some intriguing features. From the name, you would figure that they are circular galaxies consisting of bright blue stars that are relatively young. In the local universe, about 1/5 of all spiral galaxies include a ring-shaped pattern in their light distributions. In the observation of regular galaxy morphology, there are 3 major types of optical ring phenomenon. We have the nuclear rings, inner rings, and the outer rings. The nuclear ring is located near the center of a ring galaxy, but the inner and outer rings are far from the center. Nonetheless, we are done dissecting parts of a ring galaxy. There are 2 major types of ring galaxy, which are the O-type and the P-type. The O-type galaxy is a smooth galaxy with a centrally located nucleus. But the P-type galaxy is a galaxy with an up-center nucleus rather than a majorly central nucleus. Their rings are also very rough and irregular. The ring galaxies are extremely rare, and scientists have proposed that there is only one in every 10,000 galaxies. As rare as they can be, how are they formed? Astronomers have suggested that the ring galaxies are only formed by 2 main techniques. There could be more, but no other technique has been discovered. Scientists propose that ring galaxies can be formed by the collision of 2 or more galaxies, or a smaller galaxy passing through the center of a larger galaxy. Yet that is not what worries scientists. What would the effect of the ring-like transition mean for the Milky Way, which is the closest galaxy to the Andromeda Galaxy? Are we prepared for what is coming? Thousands of generations from now, our world will experience one of the scariest events, and our beloved galaxy will disappear. However, there is light at the end of the tunnel. The collision may be catastrophic for the Earth, but it would give birth to beauty. It would give birth to a whole new world. A whole new world, the birth of Milkomeda. Currently, Andromeda and the Milky Way are about 2.5 million light-years apart. But because of the gravitational field in the cosmos, the 2 galaxies are moving toward each other at 402,000 kilometers per hour. As fast as it sounds, and it is probably causing you to have a panic attack, you would have left the face of the Earth before any collision happened, both you and thousands of generations after you. Even at that speed, both galaxies would not meet for another 4 billion years. When they collide, the pair would continue to gravitate towards each other and away from each other. Stars would be formed, and there would be continuous formation till about 1 billion years. Then the solar system would be found in a new orbit, a giant elliptical galaxy formed by the collision and merger of the Milky Way and Andromeda. The scientists call her Milkomeda. It may sound like an extract from the Guardians of the Galaxy, but I promise you that it is real. There would be no alien or extraterrestrial beast-like bodies invading the Earth, but the Earth would not be conducive, since it would be trapped in the center of the collision. Everything would be wiped out. With technological advancement, new simulations of the Milkomeda have been revealed, and it is likely to be a giant elliptical galaxy, but with a center showing less stellar density than current elliptical galaxies. It is also possible that the new galaxy, Milkomeda, may be a super spiral in shape, depending on the amount of gas remaining in both galaxies. Since the Milky Way and the Andromeda Galaxy are the biggest galaxies of the local group, their collision would affect other smaller galaxies. Over the next 150 billion years, the remaining galaxies of the local group will coalesce into the Milkomeda, effectively completing its evolution. I know you don't want to be there when the collision happens, but we are dying to hear your thoughts on the terrifying message scientists received about the Andromeda Galaxy. Drop it in the comments. Don't forget to give a like and subscribe to the channel for more videos like this.